applies to the videos on limits and numerical approach and graphic approach. Well, not every time that you have a function and a value of x, you will have a limit. Here's an example. Look at this function, f of x being equal to x minus 2 over x squared plus x minus 6. Now, instead of going to x equals to positive 2 as we did before, we're going to be going to negative 3. When we do this, when we go to x equals negative 3, well, if we plug it back in, what do we have? Negative 3, we have negative 3 minus 2 is going to be negative 5, divided by negative 3 squared is going to give you positive 9, plus negative 3 is going to be positive 6, minus 6 is going to be 0. So you're going to have something of the form negative 5 over 0. So as before, f of negative 3 does not exist. Let me rewrite that 3. Got a little excited there. So we're still in the same situation as before. However, there is a problem. Whenever we plug in numbers in our function, I have the numbers already calculated. If you plug negative 3.01, so somewhere around here, the function goes out to negative 100. When you get even closer to 3, you go to negative 1,000. A little bit further closer to 3, you get negative 10,000. When you move to the other side, so negative 2.999, somewhere very, very close to 3, but on the right side, you go to positive 10,000. Then as you start going off, out, a little further out, you get to 1,000, and a little further out, you get 100. So you see what's going on. You can see it in the picture. This thing is going to behave asymptotically, and it's going to grow and go towards negative infinity as x goes to negative 3 from the left. But when you come to the right side, as you get closer to negative 3, you're going to be going to positive infinity. So in the middle here, you see the function, the closer and closer you start getting to 3, is the wilder the leap is going to be. That is telling you that there really is no limit. So since the function is decreasing without a limit on the left of x equals negative 3, and is growing without a limit on the right as x goes equal to negative 3, then we say that the limit does not exist. And this is perfectly fine. So whenever you have this situation, you just say, well, the limit does not exist. So in this case, the function was not defined, and the limit was not defined either, or did not exist. So that can happen, that's perfectly fine. Now, let's note something here. Notice that in the previous example, the limit did exist, but something different happened. When we plugged in 2 into this function, we had a 0 in the numerator and a 0 in the denominator. This time around, when we plug negative 3, we have a non-zero number in the numerator and a 0 in the denominator. This time around, the limit did not exist, and we had a vertical asymptote. So keep that in mind, because that's going to be useful in the next section whenever we learn how to calculate the limits algebraically. We will repeat these same 2 examples, but next time we're going to do it algebraically. So let's move on. I have one more example for you. And this is just, we're going to do exactly the same as we did in the first example. Is just create our table and find the values for the limit. Or find the values of the function for each value of x, and then approximate our limit. Okay, so again, if you plug x equals to negative 2 in your function, you're going to have negative 2 plus 2, 0 in the numerator, and then negative 2 cubed, that's going to be negative 8 plus 8, 0 in the denominator. So we're going to have 0 in the numerator and 0 in the denominator. We're in a similar situation as what we had in the first example. So we'll evaluate the numbers, and this will point out to the possibility of the limit actually existing. Anyways, let's plug in some numbers. So if you were to plug negative 2.01, which is close to negative 2, but not quite, then we have, this is going to be negative 2.01 plus 2 over negative 2.01 cubed plus 8. And that gives us 0.0829. Now we evaluate the next one, and then after that I'm going to fill out the whole table as I did before. So you plug in negative 2.001 instead of x, and you get negative 2.001 cubed plus 8. Let me rewrite that cubed, then it'll look that nice. And that gives us 0.0833. So let me finish the table, and we will then try to conclude something with the table. At first, just notice, just right now, that the function is not behaving wildly. It's not growing extremely fast or decreasing extremely fast. It's staying very close, so that gives us an idea that perhaps there will be a limit. Let's try to figure out. All right, and we're back, and we have then the table, and let's see, the function is behaving. Oh, I eliminated one of the columns. Nonetheless, it looks good. 0.80833, sorry, 0.0833, and the next one is going to be a 3 after. And you see, as we're getting closer and closer, when we're getting closer to negative 2, we seem to be getting closer to 0.0833, and probably this 3 periodic. Right now, as I said before, it's approximate, right? But we will be able to calculate these numbers exactly. Let's take a look at the graph quickly and see what is happening when you're going towards x equals negative 2. If my line is straight, which is not, but let's assume it is, the function is going towards somewhere around here. Let's see, 0.5, 0.6, 0.7, 0.8, 833, since my line is not perfectly straight, but it looks about right. And again, this function, since at x equals negative 2, the function is not defined, you have an open, it doesn't look very open. Let me delete a couple of points so it looks open. Let's delete a few of these, and let's make an open circle there, just to emphasize the fact that the function is not taking that value. So that is because f of negative 2 does not exist, but the limit as x goes to negative 2 is approximately equal to 0.0833 periodic. And so that's that for this. If you have any questions, you can, well, for students in the class, you are welcome to ask your questions in the online session we will have this week. All right, thank you so much. Thank you for watching, and I'll continue with an example for the next section in the next video.